So right now I have these two functions. I have y equals 3x plus 2 and y equals x minus 2 divided by 3. And what I'm going to be telling you is that these two functions, they're inverses of each other. And in the video, I'm going to just create a table of values. I'm going to be creating a table of values based on the graphs of these two functions. And hopefully you'll notice some sort of similarity between inverses of a certain function, So let's get started. Let's look at the graph of y equals 3x plus 2, which is this graph right over here. So what do you notice? It's this red line right over here. Well, when our x value is equal to -1, our y value is equal to -1. So let's write that down. Our x value is equal to -1, our y value is equal to -1. Let's take a look at this point right over here. It looks like when our x value is equal to -2/3, our y value is equal to 0. Our y value is 0, and the x value is -2/3. -2/3, and the y value is equal to 0. Let's take a look at this point right over here. Looks like when our x value is equal to 0, our y value is equal to +2. So when our x value is equal to 0, our y value is equal to +2. Now let's take a look at the blue graph. This is the blue graph. When our x value is equal to -1, our y value is also equal to -1. So that's one thing. When our x value is equal to 0, so when our x value is equal to 0 right over here, our y value looks to be -2/3. So when our x value is equal to 0, our y value is equal to -2/3. Let's take a look at one more point. Let's take a look at this point. Looks like when our x value is equal to +2, our y value is equal to 0. So when our x value is equal to +2, y value is equal to 0. Okay, now that I filled out the table, do you notice anything interesting? And you're probably thinking, whoa, it looks like the x and y values sort of swapped with each other. If we look at, let's say, this row right over here and compare it to this row, well, our x and y values basically just swapped. If we look at this row, basically everything swapped. If we look at the first rows, even, they also swapped. They're the same point, but it's like the -1 right over here swapped with -1 right over here. So that's the thing about inverses. Whenever a function is an inverse of another function, well, it's just that the x and y values are swapped with each other. And so if this is our original function, let's call this f of x, well, this would be the inverse of our function. And the way you denote that something is an inverse of another function is you write the same thing, f of x, except you put this -1 on the top. And this just means f inverse of x. So this is f of x, and this is f inverse of x. So this is the inverse of f of x. And one cool thing about inverses of functions is that if you have, let's say, f of 3, and you take the inverse of f of 3, you're going to get back 3. If you have, let's say, f of 6, and you take the inverse of f of 6, well, that's going to land you on 6. So what you'll notice is that whenever you have, like, f of x, let's just say, and you take the inverse of f of x, you always get back the thing inside the parentheses, in this case, our x value. You notice in our first example, we took f of 3. And when we took the inverse of f of 3, we got back 3, which is the thing inside the parentheses. When we took the inverse of f of 6, we got the thing inside of the parentheses. If I take inverse of f of 32, let's just say, well, I would get back 32, the thing inside the parentheses. And let me just show you this real quick, because some of y'all might not believe me. So let's see if this is actually true. So let's say I want to find out the inverse of f of 0. What is this going to be? Well, first, we got to deal with the thing inside the parentheses, the big parentheses. We want to find out what f of 0 is equal to. What is f of 0 equal to? Well, this is the function f of x. And when we plug in 0, for x, so when x is equal to 0, well, our y value is going to be equal to 2. So f of 0 is equal to positive 2. Because when we plug in 0 for x, we get a y value of 2. So f of 0 is equal to positive 2. So now, instead of f of 0 here, I could just substitute it with a 2, because they're equal to each other. Okay, so let me just write this down. So this is going to be equal to f inverse of positive 2. Equal to each other. Okay. Now, what is this equal to right over here? Well, this is the inverse of f of x. And when we plug in 2 in for x, we get a y value of 0. So f inverse of 2 is equal to 0. And what you'll notice is that our original thing we had to solve was f inverse of f of 0. And what you'll notice is that our answer is still the thing inside the parentheses. Only this time I used the tables to kind of prove this. But this is just to show that if you have f of something and you take the inverse of that something, you get back the x value that you just plugged in. Now let's say that if I have a function, let's say we have, let's say 3x plus 3. And we want to find out what is the inverse of this function. What is the inverse of this function equal to? How do we do this? Well, first off, whenever you're trying to find the inverse of a function, instead of using f of x is equal to blah blah blah, use y equals to 3x plus 3. And this will make things much simpler. So instead of f of x, just rewrite f of x as y equals 3x plus 3. Same thing. And what you're going to do is you're going to swap the x and y values. What I mean by that is everywhere you see an x, turn it into a y. Everywhere you see a y, turn it into an x. So this y is going to turn into an x. This x is going to turn into a y. And you're still left with the 3y plus 3. You're still left with the 3 here. You're still left with the 3 here. Just keep the thing the same, except switch the x and y. And what you're going to do is you're going to now solve for y. You're just going to solve for y. So how do we solve for y? Well, first off, I'm just going to subtract 3 on both sides to isolate the variable. So I'm going to get x minus 3 equals to 3y. Divide both sides by 3. And I get x minus 3 divided by 3 equals to y. Y equals x minus 3 divided by 3. And boom, there you have it. This is the inverse of our original function, which is pretty cool considering how simple that was. Let's do another one. Let's say I have y equals to 5x minus 4. Y equals 5x minus 4. What is the inverse of this function right over here? Let's call this f inverse of w. What is this going to be equal to? Well, everywhere you see a y, turn it into an x. Everywhere you see an x, turn it into a y. So this is going to be x equals 5y minus 4. And now solve for y. How do we solve for y? Add 4 to both sides. This is going to be x plus 4 equals 5y. This cancels out. Divide by 5 on both sides. You get that y equals to x plus 4 divided by 5. And that's the inverse. And If you don't believe me, one thing you can do, you can graph it out, create a table like I did before, and once again, you'll notice that the x and y values of these two graphs, of this graph right over here, and this graph right over here, well, the x and y values are swapped. Now let's move on to a trickier sort of problem. Let's say that I have y equals x plus 2 divided by x. What is the inverse of this function? What is the inverse of this function? Well, once again, I'm going to do the same strategy. Everywhere I see a y, turn it into a x. Everywhere I see an x, I'm going to turn it into a y. So this is going to be x equals to y plus 2 divided by y. All right, I changed this x into a y. I changed this x into a y. Now, what I'm going to do is I'm going to try to get both of these y's to one side. Now, how do we do that? First off, multiply both sides by y, because you want to get rid of this denominator. So you're going to get xy equals to y plus 2. Just get rid of the denominator. Now what you want to do is you want to move the y's to one side. So let's move this y to one side. So subtract y from both sides. This cancels out, and you're going to get xy minus y equals 2. Just move everything, move the y's to one side. Now what you want to do, well, you notice that this term right over here, this xy term, has a y. And this right over here is a y. So what you can do is you can factor out a y. I know I'm saying that a lot, but you can factor out a y in this case. So this is going to be y times x minus 1 equals 2. We took a y out from this term, and we took a y out from this term. So this right over here, if we take a y out, we're going to be left with x. And if we take a y out of this term right over here, we're left with negative 1. And you notice how if I do the distributive property, well, I get back to where I originally started. Y times x is xy. Y times negative 1 is negative y. So this is the same thing. These two things have the same value. And now, to isolate y, just divide both sides by x minus 1. Just divide both sides by x minus 1. So this right over here cancels out, and I get y equals 2 divided by x minus 1. Seems tricky, but I'm going to do like a couple more questions. So let's do y equals 3x plus 4 divided by 2x. First off, if we want to find the inverse of function, swap the x and y values. Everywhere I see a y, turn it into x. Everywhere I see x, turn it into a y. So this is going to be x equals 3y plus 4 divided by 2y. This x turns into a y. Second step, get rid of the denominator. Multiply both sides by 2y. Get rid of this denominator. So you're going to be left with 2y times x, or 2yx, equals 3y plus 4. Third step, get the y's to one side. So I want to shift this y to this side right over here. Get the y's on one side. So subtract 3y, and I'm going to get 2yx minus 3y is equal to 4, because this cancels out. Next step, factor out y, because we see that there's a y right over here, there's a y right over here. So let's factor out this y. And we're going to get y times 2x minus 3 is equal to 4. If we take a y out of this term, we're just left with 2x. If we take a y out of this term, we're just left with negative 3. And you could check using the distributive property once again that these two things are equal. And finally, to isolate y, just divide both sides by the thing inside the parentheses. Just divide both sides by 2x minus 3. And you're going to get y is equal to 4 divided by 2x minus 3. And there's the answer. Let's do final problem. I'm going to try to make this one tricky. So let's say we have y is equal to 7x divided by 3x plus 4. So once again, if we want to find the inverse of a function, just swap the x and y values. So y becomes x, and all the x's become y's. You want to get rid of the denominator, so you're going to multiply both sides by 3y plus 4. Multiply this side by 3y plus 4, because this gets rid of our denominator. So we're going to get 3y plus 4 times x is equal to 7y. And just to simplify things a bit, let's just do the distributive property. So it's just going to be equal to 3yx plus 4x equals to 7y. Now, I want to get all the y's to one side. So what I can do here is, one thing I can do is move the 4x to this side and move the 7y to this side. But I think the simpler strategy is just to subtract 3yx from both sides. So now we're doing the same thing. We're just trying to move all the y's to one side. In this case, I'm just going to move it to the right side now because it's more convenient. So this cancels out. I'm going to get 4x equals to negative 3yx plus 7y. And once again, you can factor this. We have a y here. We have a y here. So what we can do is we can say that 4x is equal to y times, if we take out a y from this term, we're just going to be left with negative 3x. If we take out a y from this term, we're just going to be left with positive 7. We just took a y out from this term. We just took out a y from this term. And now, to isolate y, divide by the thing inside parentheses, negative 3x plus 7. So you're going to get the inverse, where's that thing? The inverse of f of x is going to be equal to 4x divided by negative 3x plus 7.